Okay, we're going to talk about transformations. Now, transformations are sliding sideways, that's a translation, or up and down, that's a translation, or there's a stretching vertically or sideways, and those are called dilations. I'm going to give you problems that have both of those in it on the worksheet. So I'm going to do one that's a fairly complicated one, and then I'm going to come back and I'll do a couple of those, and then hopefully you'll be able to do the simpler ones. All right, so I'm going to write y equals, let's say, negative 3x minus 1 squared plus 2. Now, first thing you want to do is identify the parent function. And there's a whole page of parent functions in your textbook, but we're going to work with two primary parent functions here. This has something, the x quantity squared, so this is like has the parent function x, y equals x squared. The other parent function I'm going to work with is y equals the absolute value of x. And the reason I'm picking these two is because they're fairly easy to graph, and they're easy to tell if it's been stretched or stretched, which directions it's been stretched or moved. If I do a line, if I move it sideways, it doesn't look a whole lot different than if I just move it down, because it goes, the origin's here and I move it sideways or move it down, it goes to the same place. And so it's hard to tell what the translations are and transformations are for a line. So primarily, one of those two are our parent functions. Now, so the first thing I want you to do when you do these is I'm going to have a bunch of small graph sections for you. And you're going to pick and draw some coordinates. And since the parabola goes up, I'm going to put it there, and I want you to identify like 5 points on a parabola. If you put in 0, you get 0. If you put in plus 1, you get 1. If you put 2, you get 4. If you put minus 1, you get 1, and minus 2, you get 4. So you need to have units on your graph, at least enough to know where things are. And the parabola, identify these 5 points on the parent function graph. Okay. Then there are 4 transformations in this particular problem. I see 3 on the outside of the square and 1 on the inside. Now, the 1 on the inside is this minus 1. On the outside, there's a plus 2 and a negative 3. Well, you might say that's only 2 on the outside, but there's 3. We can choose whether to do the inside transformations first or the outside transformations first. But when you do them, do all of them all of those. If I decide to do the outside, do all of them first, and then do all the inside. Or do all of the inside, then all of the outside. So I'm going to do let's do the inside first. So I'm going to draw a new axis. There's only one number in there, so I don't have to worry about order of operations. It's subtract 1, and of course, as we've talked in class, everything inside works backwards. So minus 1 moves the parabola plus 1. So every one of these points gets moved 1 to the right. So 0, 0 goes here. Excuse me. 1, 1 goes to 2, 1. And 2, 4 goes to 3, 4. And minus 1, 1 goes to 0, 1, and minus 2, 4 goes to minus 1, 4. And that's a translation one unit right. I've given you some lines on the worksheet below it to write what's going on. So we've taken care of the minus 1. Now from here, we've got two numbers to deal with. There's the one that's multiplied by this and the one that's added. When it's on the outside, you do them in PEMDAS order, in the order of operations. So multiplication comes before the addition. So you need to do the minus 3 first. And here's where the extra one comes. There's a minus and a 3. So I'm going to do the negative first, and then I'm going to do the 3. So here's my axis, and I'm going to do the minus. So the minus is on the outside, which works in the vertical direction. So it's going to cause a flip over the x-axis. So this point at 1, 0 stays at 1, 0. The one at 2, 1 goes to 2, minus 1. The one at 0, 1 goes to 0, minus 1. 3, 4 goes to 3, minus 4. And minus 1, 4 goes to minus 1, minus 4. So that's a flip or reflection over x-axis caused by the negative on 3. Then let's do the 3. So this might take a little bit more room, but I'll put it right here. Now, if this had been moved up, it could make this a little different, but 3, this is 3 times. And if it's on the outside, it does what you expect it to do. So we expect this to move it 3 times as far from the x-axis. So this, oh, I forgot my units, 2 and minus 1. This is right on the x-axis, so if I go 3 times as far from the x-axis, I don't move. This is 1 from the x-axis, down 1, so I go 3 times as far, so it's down 3. And this was 1 down from the x-axis, so it goes down 3. And these that are 4 would move to 12. So that's going to be off my graph, so I don't need to keep those. But that's what happens to it. It gets skinnier looking because it gets stretched down. 3 is, now if you just say a stretch, that's not good enough. It's stretching it vertically. Is a vertical, V-E-R-T-I-C-A-L, vertical stretch. Now, if it was 1/3, it'd be 1/3 as far. Everything would go as, or half, would go half as far from the y-axis. Okay. So 2 and minus 2 need units someplace. And finally, the plus 2. That's going to take the whole graph and move it up 2. Instead of taking time to draw that in the video, I assume you can say take that one to there, and this one that's down 3, and take it to minus 1, and to minus 1, and it would look something like that. Moved up 2, and I would say that. Okay. Let's do an absolute value one. So let's say we had y equals, negative absolute value of, let's do 2x plus 3 minus 1. So this parent function is the absolute value function. And what does it look like? So I'm doing first the parent. So the absolute value parent, if I put into y equals the absolute value of x, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2, and 3 is 3, and minus 1 is 1, minus 2 is 2, and minus 3 is 3, and I get a v. So that's the parent function. Now, I can do insides first or outsides first. Last time I did inside first. Let's do the outsides first. Okay. And we can see we got a minus out here and a minus 1 over here. This minus is kind of times it. It's like minus 1 times this. And this is subtract, so this one comes first. And it's just a 1, so it's not going to stretch it vertically, but it's going to flip it. So it's going to go there. I needed to say that was a parent, and so this is the minus flips over x-axis. And so mark the points, at least 5 of them. There's 5 of them, and there's 2, and there's 2. So I got my scale. There's no stretch on this vertically. It's just flipped upside down. This moves it down 1. So my next graph would show it translated down 1. So it would be there. And this is 2, and this is 2. And the negative 1 takes it down 1. Now I have 2 things inside. And this is where it gets a little tricky. Okay. There's a plus 3 and a 2. But this is inside the absolute value. So everything works backwards, including PEMDAS. So this is multiplication, this is addition. We usually do multiplication first and then the addition. But when you're doing translations, you got to do them backwards. So instead of doing the multiplication first, we do the plus 3 first. Plus 3 inside on the x is a horizontal shift, a horizontal translation. A plus 3 takes it minus 3. So this curve gets moved from here to there. There. So there's 1, 2, 3, 4, 5 points. And this is minus 3, and this is plus 2. And there's my curve, and it's left 3. Now I got to do the 2. So to do that one, and I'll do it down below here, so my curve is right now sitting here. And I'll draw it kind of lightly because I want you to see exactly what happens here. 2 times. Seems like that would make it twice as wide, but everything's backwards, so it makes it half as wide, but not half as wide by this. It takes it half as far from the y-axis. So how far is this point from the y-axis? It's 1, 2, 3, so half as far would be there. So this point gets pushed to there. This point, how far is it from the y-axis? It's minus 1, 2, 3, 4, so it gets taken half as far away, so it gets moved to minus 2. And this point was 1, 2, 3, 4, 5, and so it gets moved to 1 half, 2 halves, 3 halves, 4 halves, 5 halves. That's half of 2 1/2 is half of 5. This point, which was only 2 away, gets moved to 1 away, half as far away. This point that was 1 away gets moved to half as far away. And there is where the new one is. Now, that was not a stretch. It was a compression. And it was not vertically. This was a horizontal compression. By a factor of 2 or a half. You can say it either way. I don't care because I'll understand what you mean. Okay, let's do one more, and I'll call it good for the video here. Let's go back to a parabola. Y equals 0.5x minus 1 squared plus 3. So the parent function is what I start with. Oh, let's put a minus on this here. So now I have 1, 2, 3, 4 transformations. The parent function, the parabola, is 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, 4. Those are my 5 points that I'm going to try to keep track of as they go through the transformation. And that's 2 and that's 2. Okay. Let's work with the inside first. Okay, so on the inside, everything is forward or backwards. Everything works backwards. Multiplication would normally come first. We do it last. The subtraction would normally come last, so we do it first. Subtracting 1 seems like it would take it minus 1, but it takes it plus 1. So if I draw my coordinates, this gets moved plus 1. That gets moved plus 1. That gets moved plus 1. And that gets moved 1 more to the right, and that one gets moved 1 more to the right. So my parabola goes there. Oh, forgot to write stuff here. This is the parent. Put my units. The minus 1 moves right 1, or it's a translation right 1. Translation. So let's finish up on the inside. So now let's take care of this, because if you start inside, you should finish it on the inside. So now the 0.5. All right. Well, it's got a minus on it, so let's take care of that first. So this minus is in the inside, and so it's working horizontally, and so instead of reflecting it over the x-axis, it reflects it over the y-axis. So this point that was here gets taken over to there. This one that was on the axis stays there. This one that was 1 on this side gets moved to the other side. And this one that was 2 over here gets moved to 2 over here. And this one that was 3 this way gets moved to 3 this way. So that's a reflection or a flip, whichever way you want to call it. Flip or reflection over y-axis. So I've taken care of the -1. I've taken care of the minus, but now I got to take care of the 0.5. So the 0.5 seems like it would make it half as far from the y-axis, but it's backwards. It makes it twice as far. So this point is -1 from the y-axis, so it goes to -2. This point's right on the y-axis, so it doesn't move. This point here is 2 away, so it goes to 4 away. -2, so it goes to -4. And up here, this was 3 away, so it goes to 1, 2, 3, 4, 5, 6 away. So it goes there, 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 there. And this that's 1 over goes to 2 over to that side. So it looks like that. So that was a stretch, a horizontal, in the horizontal direction. Stretch. See, it's by a factor of 2. The half makes it 2. And then plus 3. That would be just the whole thing moved up 3. Same shape. So it would be here, it'd be over 2 up 1, back 2 up 1, and you can kind of, I would do that on another one and say shift up 3. Okay? That's what I want you to be able to do with translations. And so the worksheet looks like this. You can see here that we have a parent function that's y equals x squared, and then you will do it. And if you need an extra box or two, you can make an extra one. This one is, again, the parent function looks like it's a quadratic, the y equals x squared parabola. The absolute value, and then the back page has the similar stuff. Okay, that's it.